Now we'll be looking at standard deviation, and this video will cover a few things, and there's another video that will cover other parts of the problem for this homework, so they'll kind of work in conjunction with each other. So, the ins and outs of standard deviation. Remember, we use the standard deviation to determine where our numbers are on that bell curve. Okay, so we've got two situations. Joe has these test scores. Sammy scored these. If we find the mean, the average, they're both at 80. So, by looking at standard deviation, we can see that spread at how far away they are from 80. Now, this paper was given in class, so you should have it and be able to follow along. Keep it as notes, okay? So, we've got the example here, and then we'll work through it down on this side. So notice, first thing we did was we found the mean by adding all the numbers, dividing by how many there were. And we use X bar to represent that mean. So for Sammy, same idea. Okay, and it was 78 plus 78 plus 79 plus 79 plus 3 82s, right? Yeah, which I'll run out of space for. 82 plus 82 plus 82. And all of those will be divided by 7. And if you type that in, you end up getting 80 as well, which is kind of what we already talked about. So the next step is we have the deviation. Okay, to find the deviation, you take those original scores and subtract 80 from it. So in other words, you're trying to find what the difference is, essentially, how far away from the average these numbers are. So we do the same thing. So 78 minus 80 would give us negative 2. We do it again. Okay, 79 minus 80 would be negative 1. And we do that twice. So I'll put another one down. And then 82 minus 80 would give us 80, and we do that 3 times, which that would give us 2. Okay, once we have these new numbers, we take those and we're going to find the variance. To find the variance, we square all the numbers. Okay, so they took all these deviations, squared them, and then with those new squared numbers, found the mean. Okay, so the average once again, and came up with that variance, which we represent with s squared. So we do the same thing. So negative 2 squared would give us positive 4, so this would be positive 4. Negative 1 squared gives us positive 1. So we've got 4 plus 1. This would be a positive 1 as well. And then 2 squared would give us 4 again, so we have 3 more 4s. All that divided by 7. So add those all up. 1, 2, 3, 4, 5, 22. So 22 over 7, which becomes 3.14. I think it's like 286. Okay. So that's our variance. Then the last step is we simply take that variance and we get the square root of it. Okay. When we take the square root of it, that gets our standard deviation, which is 1.77 something else. I can't remember at this moment, and my calculator is not right here. So I grabbed my calculator. It's basically 1.77281 is where we kind of rounded. So then you notice the difference here, okay, which goes to tell us that yes, Joe's scores were very spread out. We can see that because their standard deviation is 14. Whereas Sammy's were all close together, and we see that in the 1.77281. So you can see that the deviation is higher because it's more spread out. There's more variation to it. Okay, and whereas Sammy's are closer together. Okay, so if you were to predict that, you could easily predict, for Sammy, he's going to score around that same area, right? Remember that 3 standard deviations away is 99.7%. So, and 2 standard deviations was 95. So for Sammy, 2 standard deviations away, that's 1.7. So his a mean of 80, 1 would be 81.77, 2 would be 83.54, something like that. Going the other way, 1 would be, subtracting that would be 78.33, and then subtracting that would be like 76 point something. So he's going to score within a 76 and an 83 95% of the time. Okay. Now if we look at Joe with his 14.11, okay, that same idea, 95% of the time, okay, 2 standard deviations away. So from 80, he goes up to 94.111, and then goes up to 108.222. Going down, he would be, let's see, 70 minus 4, 66, or 65.999. And then down further would be, 51.888. So he can go anywhere from 50% to 100%. Okay? So that's not as consistent as Sammy. Alright. Now in the other videos, I've already done a bunch of these, so I'm not going to do these. You can watch the other video to get some help. Just know the other video is going to talk about the Z-score, which is what we're going to be doing next time, so you don't need that necessarily. But you can do it for the other parts. And when we're doing standard deviation, you don't want to do it by hand. Okay? We have calculators, Excel spreadsheets, we have programs, we have things that can help us do that. Okay? So we don't need to worry about doing those by hand. Let me see which ones we need to do. So we'll take a look at this monthly review one and the president's one. All the other ones are on that other video, so you can watch those for that. What we're not going to deal with right now is the Z-scores. Okay, so we're basically, getting rid of those. Alright. So, monthly review. So the first thing we need to do is figure out the mean, right? And the standard deviation. So the way we find the mean is using a calculator, because I'm not going to do this by hand. 46060 plus 5890 plus 5640 plus 61540 plus 64170 plus 65150 plus 66460 plus 75840 plus 82250. Okay, and I divide that by 9, and so my average, my mean, would be 57555.6 if I round. Okay, so maybe we just round up to make it a little easier and go 6 right here. Okay, which is fine for this. Okay, now to find the standard deviation, I have to subtract that from all of them. So doing that by hand is very time consuming and difficult. Okay, you can do it, okay, but it's easier to probably use an Excel spreadsheet, use a calculator, something that can do that for you. So I'm going to hurry and do that, but I'll talk you through. So what I do is I put in my numbers, okay, then we found the mean already, so then I'm going to subtract the mean from those numbers, okay, and doing that will give me that deviation, how far away they are from it, okay. So I get all those numbers, then I'm going to multiply the numbers together. That gives us that variance, okay. Once we've got the variance, then all we have to do is find the average of that, and then we're going to take the square root of it. When I do that, I should end up with 12,101.87, so we'll just say 102. Okay, to make it a little easier. Now, once we've got those two, now we can draw our curve. So I pick one of these lines as my mean. So that's 57,556. Okay. Then we kind of just draw a curve like this. That was a pretty good one. And then we're going to go one standard deviation away, which remember, together are 68%, and separated are 34 and 34%. So I'm going to have to add and subtract that to here, okay, to get this next point. Okay, so 57,556 plus 12,102 gives me 69,658. Okay, then it's usually easier to keep going, right? So then I add our, we're going from this one now over, okay, which remember by itself was 13.5%. So I add that 12,102 to that, and that gives us 81,760 right here. And then I'm going to do it one more time and get 93,862. Okay. Remember, from here to here, that was 2.35%. Okay. Now I'm going to go backwards and go to the left. So I go 57,556 minus 12,102. That gives me 45,4. Okay. And then we're going to go again down. So I subtract 12,102 from the 45,4. I get 33352, 33,352. Then we do it one more time. And remember, again, this is 13.5, making 2 standard deviations away, 95%. Not that you guys have to write those, but just informing you. Okay, do it one more time. I get 21,250. Okay, making that 2.35% again, and making 3 standard deviations away. Oops, I went too far, didn't I? Is 99.7%. Okay, for right now, that's all you need to do. Later, we're going to use this number, 32,024, which would be about pretty close right here. We can find what that percent is to the left and to the right to inform us about that, and that's what the z-score is going to help us do. Okay, so let's do one more. So this one with the presidents. Okay, so looking at this one, we've got all these ages. Okay, so once again, what I'm going to do is I'm going to type those into my Excel spreadsheet, or using a calculator, or maybe a website where it's got that same information. We can figure this out. Okay. So we find the average, okay, by adding all those ages up, dividing them by, looks like, what, 10? Okay. So we add those up, we divide them by 10. We take those numbers, and we find us the mean, right? Which our mean, when we added them all up, was 54.9 and divided. Then we need our standard deviation. So we take all these numbers, subtract them from 54.9. Okay, we find that deviation. Then once we've got those numbers, we double them. So, well, not double them, we times them by themselves, square them. Okay, then we take that, all those squared numbers, add them together, divide them by their number, find the average. Then once we've got that, we take the square root and get our number, which is about 6.99. So nearly 7. You could probably round up to 7 if you really wanted to. These are smaller numbers, so I'm not going to. So then we've got our mean here of 54.9. We can draw our curve now. Do the 1 standard deviation, 2 standard deviations, and 3 standard deviations. away. So I take 54.9, and I'm going to add 6.99. So that gives us 61.89. Okay, I'm going to add 6.99 again to get 68.88. And I do it one more time to get 75.87. Okay, then we go backwards. 54.9 minus 6.99 to get 47.91. Subtract it again. For our 2 deviations away, 40.92. And one more time, get 33.93. Okay, so then we know 68% of the presidents are going to be within that almost 48, 47.9 to almost 62. Okay, that's where 68% of our presidents' ages would be on their inauguration. 2 standard deviations away, we're going to have 95% of them, right? So, and then 3 standard deviations away, we'd have 99.7% of them within that. So most likely we're not going to get like an 80-year-old. And we can't get like a 32-year-old because you have to be at least 35 to be president. Okay? So, then later, next time we'll learn. So, if George Washington is 57, he fits in this 68%, but how many below him were younger? How many above him were older? Okay, and we'll figure that out. So, watch that other video if you need to see some of the other stuff to make sure you did your bell curves right. And there we go.